All right, so let's get screen down. All right, so let's see what notebook we use today. I just saw them. I think they were on these specific ones. They were on Amazon for like 15. That's the cheapest I've ever seen it. Usually you can get them on sale for like 25. I think they're normally 30 maybe. I don't know, but 15, that's a deal. So if you were looking to buy one. Okay, everybody has a notebook out of some sort. All right, this is section 3. -2. Adding and subtracting rational numbers. All right, so before we even get into it, we got to remember what rational numbers even are. Can someone tell me? What are rational numbers? If you don't have a notebook out, is it because you need a piece of paper? I could let you have one. Do you need a piece of paper? Come on up. Do you need a piece of paper? You sure? Can you get one out then? I don't think that it's not really going to be conducive to what we have to do today. You're better off with paper and a pencil or pen. Okay, we ready? So rational numbers. These are the numbers that you can write as a fraction, where the numerator and denominator are integers. So they really kind of encompass all the whole numbers, right? So, positive and negative. So those are all the integers. But now we're adding on another layer. Now you can write them as a fraction or as a decimal, as long as that decimal terminates or is repeated. So there's kind of a lot packed into that one word, but it's important to remember what they are. So rational numbers. This is any number that can be written as a fraction. Where numerator and denominator are integers. We've already talked about some of these definitions. I just wanted to refresh your memory. So I'm actually going to make a list of what types of numbers are included. All those whole numbers, all of the integers. decimals that end, or we usually use the fancy word terminate. It also includes decimals that repeat. And I'm going to add fractions as long as top and bottom right integers. I remember learning about rational numbers, and I don't know, I'm not going to say that I was not taught this. I probably just missed it. But I always remember hearing, and maybe I just misheard, that rational numbers are just any number that you can write as a fraction. So I'm like, okay, well, I know pi is irrational, and I can write pi as a fraction. I can write pi over 1. So, but I know that that's irrational, so it doesn't fit this definition. It's because I was missing this piece, that the top and the bottom have to be integers. So that's kind of a big deal, but we leave that out a lot. We like to just say, oh, any number that you can write as a fraction. Well, you got to add that piece to it, because then you could write any number. You can write any irrational number as a fraction. So you need the part about top and bottom being integers. All right. So if we look at this list, we've already talked about adding and subtracting and multiplying whole numbers and integers. So we already have done that. We're going to talk about adding and subtracting decimals today, and we'll see how far we get with fractions. So we're going to kind of look at two pieces today. We'll start with decimals, adding, subtracting. We're going to try and not use any calculators today. And then we'll see what we know with our fractions. People never seem to like the fractions, but it's just numbers. Don't worry. Okay, ready? Everybody has this list. So let's, here, I'll leave the, if you still are writing that list. So let's start off with decimals. How to add or subtract decimals. So let's do an example problem, and maybe you could tell me what you're supposed to do. Say I wanted to do something like 4.75 minus 3.2. Do you remember how to do this? You probably learned this at some point a long time ago. You just probably haven't done it in a long time. Everybody remember? Connor? Say it again? Oh, you just know the answer. Well, if you are looking at this and you don't know the answer, what you should do whenever you are dealing with decimals, you want to line the decimal points up. Always take your bigger number, put it on top, and you're going to minus the smaller number, even if it's written in the other order, right? I could do 3.2 minus 4.7. But I have to know, if you're going to do that vertical method where you subtract the numbers, you have to have the bigger number on top. It doesn't work the other way. You would just need to know, okay, I need to find the difference, and then I'm looking for the sign of the bigger number. So anyway, in this case, step 1 would be to line up your decimals. So I would write it as 4.75 minus 3.2. See how I have the decimals lined up, not necessarily the numbers. If you have a blank space after any of your numbers, like I do here, there's nothing here, you can fill it in with a 0 so that they all have the same number of digits. So you can fill in any empty spaces after a number with zeros. That's not changing the value. 3.2 and 3.20 are the same thing. And then I can just subtract like I normally do. So remember, you're just going to subtract straight down. 5 minus 0 is 5. 7 minus 2 is 5. 4 minus 3 is 1. There's something else I have to do. Do you remember now that you see it? I have to. Yeah, you bring that decimal place right down. So as long as they're lined up, you just bring it straight down. Bring down decimal. And then I'm going to add one more step. If I do 4.75 minus 3.2, that should be a positive number, right? 4.7 is bigger. So this answer makes sense. I'm done in this case. If I were doing it the other way around though, right? Because I can do 3.2 minus 4.7, but if I'm going to do this vertical method, this only works with the bigger number on top. So I'm just going to add as a last step, make sure the answer that you got is the right sign. Double check sign of answer is correct. So this one is, so 1.55 would be my final answer there. Let's do a tougher example. Let's say I want to do something like 0.003, and I wanted to subtract from that, I don't know, 0.25. So if I want to do this, can you tell me if my answer should be positive or negative before we even do it? Is my answer going to be positive or negative?
Negative.
Negative, for sure. I have a really tiny number and I'm subtracting. 0.25 is still small, but it's bigger than that one. So I know my answer is going to be negative in the end. Right? So in order to do this though, remember I need to, if I'm going to write it vertically, I need to line up the decimals with the bigger number on top. I need to remember though, oh, because it's really the other way around, my answer is going to be negative. All right, so there's step one. I lined up the decimals. You can fill in, they don't have the same number of digits, right? So this one, if I want to add in a 0 right there, I certainly can do that. And I do want to do that. So let me do that. So now everybody has the same number of digits. And I'm just going to subtract straight down. Do you remember what you do when you can't, I can't do 0 minus 3, so what do I do?
Take from.
Yeah, you got to borrow from your neighbor. 10 minus 3 gets me a 7. Now I'm subtracting straight down. 4 minus 0 is just 4. 2 minus 0 is 2. I'm going to bring down that decimal. But now it's up to me to know that the answer is negative 0.247. Right? It's always going to come out positive because I always have to put the bigger number minus the smaller number. So I have to think about it. That's why step 5 is so important. So negative 0.247 is my final answer. right? Because it's always going to come out positive because we're always going to do the bigger minus the smaller if I have to do it by hand, right? If I have a calculator, the calculator is going to do it for me. But we all know we don't always have a calculator, unfortunately, or I shouldn't say that. You all do always have a calculator in your pocket. It's just a matter of, are you allowed to use a calculator? Sometimes yes, sometimes no. Oh, I guess I jumped right to subtracting. What about adding? I should start with adding. I guess this is well, let me change step 3, subtract or add. It's an addition problem. You do addition the same way. You just don't have to worry about if everybody's positive, right? You're just adding them together. So let's do an addition one. So I gotta flip the page, sorry. I have to, let me see, do I have another blank page in here? I might have to clean it. Give me a second, sorry. I didn't realize they were open. Okay, let's do an addition one. Let's do 2.041 plus 0.53. Okay, when I'm adding, I still want to line up the decimals. I have a little bit more liberty though, because I actually don't care who's bigger and who's smaller. Just out of habit, I'll probably still put the bigger one on top, but it really doesn't matter. So notice how I'm always lining up the decimals. It doesn't matter how many digits are in each number. Just make sure those decimals are lined up. Now I come in. I never like it when they don't have the same number of decimal places, so I can just stick a 0 on the end. I'm just going to add straight down. 175 decimal 2. Done. All right, but what happens when I want to add two numbers together that are both negatives? Exactly. I add them together and I just keep my answer as a negative. So let's try another one. Say I had something like negative 14.013, and I wanted to add to that negative 7.1. So again, I need to be thinking about this, and I need to be saying, oh, I have a negative plus another negative. I'm really just going to add these two numbers together and keep the sign negative. Right? So when I go to do this, I'm still just going to line up my decimals. But notice I don't really care about the negative right now. I just know that my answer, I even want to put it down here so you don't forget it, the answer has to be negative because both of my numbers are negative. So by add them both together. All right, now I come in here and I'm like, ooh, look, I'm going to put in 2 zeros so that I can line them up. And then I'm just adding straight down. 3, 1, 1. That's 11. There we have it. All right. What happens when one's positive and one's negative? So let's do one. Let's get an example up here. Say I want to do, I don't know, 16.673 plus a negative 4.45. I don't know. Say it again. Yeah, this is going to end up being a positive number. I have positive, just ignore the decimal for a second, a positive 16 and a negative 4. So if I combine those, I'm definitely in the positive realm. So I don't know exactly where, but I'm somewhere kind of there. So I know my answer is going to be positive. But what operation am I really doing with these? Am I going to add these numbers together and keep it positive, or am I going to subtract these numbers? You got to subtract. Anytime your signs are different, just like with integers, right? If the signs are different, you actually have to subtract these two numbers. It's only when the signs are the same that you add them. Either two positives, we add and keep it positive. If it's two negatives, I add and I keep it negative. If the signs are different, though, you're always going to be subtracting. And then you got to ask yourself if this end answer is going to be positive or negative. Okay, so this one, I really need to subtract. So I'll even add subtract because the signs are different. Okay, so we're going to take the bigger number, 16.673, minus the smaller number, 4.45. Oops, I did not do a good job of lining up the decimals. 0.45. There we go. And now add in that 0. Now I subtract like I normally do. 3, 2, 2, bring down that decimal, 2. Oh, that's a funny number. Lots of 2s there. Oh, did you notice over break we had Tuesday? It was 2/22/22 on a Tuesday. No, some of you, yeah. It will never happen again that a date with all 2s will land on a Tuesday for the entire existence. The rest of the length of time the earth will exist, it's never going to happen again. That a date with all 2s lands on a Tuesday. Isn't that weird? Because your next opportunity is 22/22, right? That year to have another set of 2s. It's like a Wednesday or something. And then if you keep going out for all the next 2s, never happens again on a Tuesday until like, it was like 66 quadrillion years or something. No, more than quite, it's like so many billions of years, more than, I don't know, it was a lot. It was a huge, massive number, way longer than the earth is going to exist for. Isn't that crazy? Anyway, side note, I got excited about that. So let's try one more. Let's do what if I had, let's do this, negative 6.37 plus 12.459. So I ask you, before you even start, are you really going to add these two numbers together, or are you going to subtract these two numbers? Who can tell me? What are you really doing? Are you going to add these together, or are you going to subtract them? You're really going to subtract them because they have different signs. Anytime you have different signs, you're really subtracting. I know that's a plus sign right there. It doesn't matter. If my signs are different, I have to subtract. So if I ignore the signs, then the bigger number is this 12.459. So that one's going to go on top. 12.459. And I'm going to subtract from it the 6.37. Fill in the 0. I'll do my subtraction. I have to borrow on this one. It's 8, 0. Borrow again. But now I have to stop and ask myself, is this the right sign? Should it be positive 6.089 or should it be negative? Should be positive. Because if I go back to the originals, this 12 was much bigger, right? That's the bigger number and its sign is positive, so my answer should be positive. So we're going to subtract because signs are different. Answer is positive. It's bigger. What's going to happen when you want to add 3 numbers together or 4 numbers together? All right, I got to flip. So hopefully you have what you need. Wash one again. All right, let's flip and let's try with 3 or 4 numbers. Okay. We'll start off with the easier one and then we'll move our way up. Say I had negative 3.75. And I want to add to that to negative 2.3. And I want to add to that negative 0.12. Oh, I'm sorry. There we go. So if I wanted to add all 3 of these numbers together, we got kind of lucky here because they all have the same sign, don't they? So what do I do when they're all the same sign? Whether they're all positive or all negative, I operate the same way. I'm just going to add all 3 together and I just keep the sign that they already have. So my answer, I already know is going to be negative because all of my numbers are negative. So if all my numbers are negative, my answer is going to be negative. Okay, so I'm just going to write that to remind myself, answer must be negative. So I'll come back and revisit that in a moment. For a second, I just ignore everybody's signs. I'm going to add them like I normally would. I'm just adding, so it doesn't matter who's bigger, who's smaller. So I'm just going to line up all of my decimals, 3.75, 2.3, and 0.12. Notice I don't care about the signs because I'm just going to add them all together. And I know my answer is going to be negative. I don't have to worry. So I'm gonna fill in spaces with zeros, so that, can I put a 0 right here? Yeah, that's not gonna change anything. And I'm just gonna add straight down. So I get 5 plus 0 plus 2 is 7. 10, that's 11, right? So 1, carry the 1 over. 6. Bring that decimal straight down. So my answer is just going to be a negative 6.17. Make sure you notice you've got that negative in there. That's a big deal. All right, well, that's great. But what happens when all of your numbers are not the same sign? Some are positive, some are negatives. Uh-oh. Now you got an issue. So let's try one where they're not all the same. Let's have a 4.63 plus a negative 8.05 plus another negative 2.11. Could someone make a suggestion? What should we do?
Negatives first.
I would as well. I would say, hey, look, I do have these two negative numbers. In the end, I'm doing addition all the way across, right? I'm adding all three numbers. So why don't I just combine my two negative numbers? I know when I add those together, it'll just get me another negative. And then I'll just have one time where I have numbers that are opposite signs. So I would do that. I would add these two negatives together. So I'd have 8.05 and a 2.11. Again, I just need to know that my answer is going to be negative there. So I'm adding two negatives. So that's a 6, 1, 10. Make sure I put the negative. So now I have converted this 3-number problem down into a 2-number problem. So now I can just do 4.63 plus a negative 10.16. So remind me how to do this. How do I do it when the signs are different? What operation am I really doing? I have to subtract these numbers. Okay, I don't care what operation that says. If the signs are different, I have to subtract them. So ignore the signs for just a minute. I put the bigger number, which is 10.16 on top, minus the smaller one, 4.63. I'm going to do my subtraction like I normally do. I'm going to have to borrow. But now I need to ask myself what the sign of this answer should be. Is it positive or is it negative? It's negative because that number was bigger and it's negative. And that's why, because the 10.16 is bigger. So my final answer is going to be negative 5.53. Making sure that I'm noting, yep, it's definitely a negative. That's my final answer. So far, so good? All right, we're going to pause here for lunch. And when we come back, we'll try some fraction stuff.